All right, welcome, ladies and gentlemen, to Open Live Q&A. This is week number 143, and my name is Mr. McLogan. Thank you so much for joining me on this live stream, where I am very excited to check in with all of you, answer your questions, as well as kind of talk to you about some thoughts tonight that I think students that particularly struggle with math, I think are kind of come up with these thoughts. So I definitely want to get into those. I think it's something that's pretty helpful if you've ever kind of accepted the premise that, saying it like as yourself, like I am not good at math or I cannot be good at math. So definitely excited to kind of go over some thoughts that the thoughts that I think a lot of you sometimes are creeping in our head that, to be successful in math, we got to make sure that we kind of understand where those thoughts are coming from, why they're coming, to our head, and then what we can do about them. But before we do that, I want to say hello to Aaliyah. And Ashan, that dumb class doesn't get you an A. Armand, good to have you on. And Jesus, thank you so much, guys, for joining me in tonight. All right. So, as always, guys, just a reminder: if you guys do have questions that you would like some math questions that you'd like me to go over, I do have a couple of questions that I've already selected that I am going to go over because I do get questions each and every day. Well, not maybe each and every day. I'm not really sure, but you can definitely go to brianmclogan.com/Q&A and submit a math question there. You can always post things in the chat, but I really kind of like to keep the chat into most things, around math, not like actual math problems esque. So if you do have a math question, go to brianmclogan.com/Q&A. That is the best, fastest way. And I always try to like kind of check that before I'm done with the stream, depending on how much time we have. And then also, if you have not already joined the Discord server, I'd highly recommend going and checking out there. There, you can actually get questions answered all throughout the week. So, whenever you're having an issue with your class, you don't need to wait till a Sunday night at 9 p.m. to, ask me a question. You can just go over to the Discord server and post inside there and get help or help out some other students. Like, that's a great way to get better at mathematics. Where does I say? Hey, Rayad, and hey, Grassel. I'm getting to school tomorrow. My birthday is on Friday. Well, awesome. Happy birthday. Early happy birthday. And you're turning 17. That's awesome. I thought I saw something. Let me see. I thought somebody said, oh, yeah, I was able to go from V. Good job, Riley. That's so awesome. Yeah, and I know that, we're kind of coming into a lot of you have kind of been in school for a while now. So now you're kind of getting into that grade session, kind of grades where, grades are now starting to get posted yeah, you got to kind of like figure out where you are at. Right. And not so much like where you're at, but like how can you kind of approach things? And what I want to talk to you guys about tonight, is something that we can, I think a lot of us can kind of battle it for a really long time, but it's something that you can kind of go back through, and it doesn't matter when you get a grade, doesn't matter when you're finishing a test, for whatever main reason, you can go ahead and, apply kind of like this reflection upon your thinking, because I think it is something that is very, very common, for students that struggle with math or students that believe they are not good math students. But before I get to that, let's go and see. Evan, just curious, why did you stop teaching? A lot of reasons, but yeah, I taught 14 years inside the classroom, and yeah, it's, I wanted to expand, teaching, and I wanted a little bit more flexibility with my family. Had 3 daughters now, really, really young. So that takes a lot of time. And yeah, there's 2 options. There's a couple other reasons to go into there as well, but I'll just keep it simple here. And hey, Kevin, good to have you on. Yeah, do as many practice problems as you can. Actually, if you check out last week's stream, or maybe the stream before that, or actually, never mind, I talk about a math video. I think like my math tips for like every class. I think I would just kind of follow like those math tips, like going through all that stuff. That'd be really helpful. I have a geometry exam tomorrow. There's only one part I don't understand. How should I study for it? Well, I mean, if you got to pick and choose. Like, you can't understand everything, right? I mean, you can, but it's like you gotta understand like what's going to give you the biggest effect, right? So focus on what you can understand, what you can learn, what you can do. Don't try to overextend yourself, because it's okay. There are going to be some things maybe you won't be able to get 100% right on your test. That's fine. No, you don't need to understand physics to understand vectors. You can definitely learn vectors outside of physics. Anyone can pass math. You just need to put in the work. Yeah. And what I'm going to talk to you guys about tonight is also going to go a little bit more into that. No, synthetic division does not always work. It's just the way that it sets up for on there. And so, yeah, long division is going to, always work. But yeah, the synthetic division just kind of comes into, there's some ways you can get around it with synthetic division, but yeah, you just want to make sure for synthetic division, you're doing with a linear divisor. That's the main thing you want to have. Do you have to simplify fractions in a hyperbola? I would kind of need to see an example of where you're being, but no, I believe no. Typically, the hyperbola equation you want to leave right in there. Ethan, all right, I think I'll try to get to maybe a couple more questions that I'll get into. Hey, Mr. Gola, I'm a couple weeks through calculus, my first college year. So far, doable. Awesome. I'm a math trooper. I put in the effort, even though it's challenging. I'm liking this way more pre-cal. Yeah, I think a lot of students can probably agree with that as well. Once you've kind of overcome the kind of struggles of getting ready into upper level mathematics, that sometimes calculus is like, this is actually a little bit easier than what I was doing. Hey Zumi, is it normal for teachers to base the whole course, the test quizzes? I mean, I wouldn't say I don't know normal. I would say that my tests in my class was usually around 80 to 85% tests and quizzes. So it was very heavily weighted on there. But I also gave students a lot of opportunities to improve upon their grade on those tests and quizzes. So even though it was heavily weighted, they still had plenty of opportunities to improve their grade. All right. So let's go ahead and talk into, because I don't want to get into too many of these questions into there. If you guys do have a chat, I will come back into the chat for on you guys, but I did just want to get into the questions, at least on this live stream, and just kind of talk about like the thoughts that a lot of students come into that kind of feel like maybe they're not good enough for math, or maybe I think I said, in the title, like I'm not a math person. So there's kind of three thoughts that these type of students, and again, this was me too, right? So I'm not only am I going off of my experience as a teacher, I'm also going off of my experiences as a student. And I think the one thought that students have when they struggle with math is their thought about the future. Their thought about the past, right? So that can be past experiences, that can be past failures. Anytime that we have, it could be past experiences, past failures. It could also be like from what past people said about them as learning. Like I get it all the time in like comments. People always say like, "Oh, my teacher said I was stupid," or parent or friend said like, "I'm never going to be good at math." Like that can stick with students. That can stick with students for a very long time. Sometimes people for like their whole life, they will just hold on to some things that people said, right? Sometimes you fail a test and you just like, that's it. Like you just have like proven to yourself that you are not going to be good at math, or math is not right for you, right? Or maybe you had a bad class, or maybe you had a bad teacher, right? Whatever kind of bad experience that gave you a bad taste with mathematics. I think a lot of times students will really hold on to those past experiences or to those past failures. And what they want to do is they want to say, well, here is what happened in the past, and that is what is now going to be true for the present as well as for the future. And that is not the case. We really need to make sure we understand how we feel about those past experiences, how, what people said, what people did, what we did, and really just kind of take them from there, learn from them and grow, but just understand like the past is not going to predict our future, right? And I always tell the students all the time, like there's no grade, there's no test, there's no quiz that is going to define you, right? It is okay to struggle. It is okay to fail, right? But that does not mean that is what you are or what is going to predict in the future. So time and time again, whenever somebody says like, I'm not a really good math student, or math is not right for me, they can usually always kind of relate to some kind of past experience, some kind of past struggle where they just had a bad time. And like, that was kind of it. Like that is the truth that they accepted. And then they just kind of, held on to that, and they never really wanted to try to overcome with that. So, if you can relate to that, I'm not that good at, or I'm not a math person, or I'm not that good at math, try to go back into like your past, try to go back to like a test, a quiz, a class, a teacher, some things that people said, and really kind of see is like, those are some things that you're still holding on to, that's helping define your wanting to accept that your struggles with math as being true. And hopefully, if you can come over those paths, again, that's going to cover for a lot of students, but maybe not some others. I think a lot of students also that struggle with math is it. A lot of times, also, it's because how they think of the future. And this one is really hits hard for a lot of math teachers because I think we can all agree, and probably the most common thing that we get all the time is how is this going to relate to real life, right? I mean, people are like, why are we learning this stuff? Like, why am I stressing? Why am I doing all this stuff? Um, like, why are we learning math? Why is this going to be helpful for us? And I think, I mean, that's a big issue. Like, I think we've as being a part of like the educational sector on the other side, like I think we've done a really poor job really selling math education. And I think we've just kind of, pushed it along. Like obviously there's been a lot of important reasons why we want students to be taking different courses, different mathematics, right? And then I think it's just kind of involved to where it's just kind of like this, you know, shut up, be quiet, and just do the math, right? And we've just kind of like avoided really kind of the question and just kind of beaten around, like just kind of gone around it and like, oh, you need math. It's all around in real life. It's gonna make you successful. It's gonna do critical thinking. And like there's a lot of truth with all of that. But I think we still sell a lot of mathematics that is not needed and is not going to be helpful for the majority of students. Like, obviously, we need engineers, right? Obviously, we need people that are very, very strong in mathematics. And obviously, we want a general population to have very high critical thinking skills, to be able to think rationally, to be able to do basic mathematics. Like, and actually, I would even argue past basic mathematics. I don't think just the idea of like, you should know how to add, subtract, multiply, divide, and like you're good to go. Like, no, I really do believe there is a benefit to having students with a strong mathematic background, no matter what they are going into, even if they are going to become a ballerina, as sometimes I'd like to be able to say, like it can completely it's not dependent on just everybody that wants to be an engineer or like a math teacher or an accountant, or an actuary or anything like that. But I think I kind of got off my top of my head. I think I still think though there's a lot of math that we are teaching that has been a part of our curriculum for a long time that kind of probably needs to go out to the pasture for majority of classrooms. I think obviously when we look at the big debate as far as like calculus for statistics, like I think there does need to be a really big push into students understanding statistics and understanding data analysis, right? And I think a lot more students should understand calculus. I think a lot more students should know calculus. But what is the problem with that? Is well, I think also we have a big like entry, right? A big barrier entry into calculus, which is great for like a lot of what we want people to be learning calculus. For like obviously as I mentioned, like engineers, or if you're going, physics or anything like that, the or computer sciences, whatever may be that case. But I also think like we should make calculus much more accessible to the population of math students, right? It should not just be held for students that have such a strong background in algebra or that cover trig. Like we can adjust our curriculums to give students a little bit more of that like curiosity into what they're learning or how purposeful this stuff can be. So obviously we could probably spend a whole live stream, and actually probably we could make up a whole channel. We could write some books. We could talk about a movie, about all the failures of math education, of what we're teaching, what we should be teaching, how we should be teaching, and all that kind of stuff. But I think the main thing is like, we got to really kind of resonate with why we're learning what we want to learn. And again, like for your perspective as a student, what are you trying to go into, right? Are you going into a math field? Are you going into a field that is strong in mathematics? And maybe if it's not, like, it's like, all right, so why am I learning this? Like, let's say you have no actual need for mathematics, but you find yourself in pre-calculus or in calculus or something. You're like, crap, I have to take this class. I have to get a good grade in it. And you know what? Like, I think there's a lot of times in life where students really have a tough time, like accepting that they have to learn something, or they can't, if they don't learn something that is immediately applicable to like real life, then it's just completely useless. And I don't want you to hold on to that belief. And again, it comes to students all the time. Like, I'm sure you guys have seen maybe the shirt or the meme, like, it's been this many days since I haven't used algebra, or whatever may be the case. Which could be completely true about like a ton of classes that I took in high school as well as in college. So I know that math usually gets the butt end of the joke for those type of things, but there's a ton of stuff that had to learn in college. I studied, I crammed, I did note cards, and I haven't used it or remembered what exactly it was since I did it there, right? So it's not just in mathematics, but anyways, what my point is, like, there's a lot of things that we kind of have to just like get over. We just have to do, right? So I mean, if you need a certain GPA, if you need to, you're going for a scholarship, if you need a certain class for a degree, and even if like you're never going to probably be using that information probably before, like you got to like that's when I think of like how you think of the future, like that is what you need. You got to be able to understand, hey, I need to be able to overcome this struggle, in this class. And because I'm looking for something much bigger. It's not so much about learning the math. It's about, achieving either that degree or that, or getting that grade, whatever I need to be able to move on to the next step, right? Passing this math class, doing well in this math class, understanding this certain material, passing the test, whatever it may be, is just kind of a stepping block, right? So you really got to think about that future. Um, you really got to kind of believe, that what you are learning is going to be useful. Because I think with a lot of students, when they struggle with math, which I probably should have started this whole section on, is they don't believe that anything that they're doing is worthwhile, right? And of course, like they're like, this stuff is stupid. There's no point in me learning this, and there's no point in me doing good in this, right? So, and that's usually why they're going to put in a lower effort, right? And they're not going to have any motivation to learn the material, or when like the going gets tough, they're just going to quit, right? And they're saying, let me relate back to my old past experiences where I did struggle, where things were hard, and and let me make that with the truth. The last thing that I think students that struggle with math that they can relate to is how they feel about themselves. And so we talked about how you feel about the past. We talked about how you feel about the future. And I think that students that struggle with math also just believe that, kind of going into that fixed, and mindset is like, they just believe like, hey, if I've struggled with math before, like that's it. Like I'm done. I cannot improve upon my ability in mathematics. They don't believe in themselves to be able to overcome some struggles. They don't believe in themselves that they can work harder and achieve things that they barely even feel is like possible. Um, and, um, and I was going into, but not so much in the belief, but also in the feel of like they can change, right? So, whatever happened last year does not necessarily mean it's going to be happening this year. And what I want you to really believe is like, it's a very difficult thing to kind of like ingrain in students. And that's something I found. Like, I remember reading like the Fixed and Growth Mindset book a long time ago when I was like a teacher. And like, it's not just something that we say, oh, here's this new mindset. It's not really new mindset, but it's like, oh, here's this like idea or the simplification of like how I want you to like to go approach things. And like now just go and apply it. Like now it's there. So now you know what it is. Like, so just do it. It's not as simple as that. Like, it's tough. It really is tough to put in the time to like, to make a change, to believe in yourself that what you're doing is, worthwhile, to believe in yourself that you can overcome things. But I really believe that students that can be successful in mathematics, they believe in themselves. They believe in what they are doing. They believe in their ability, and they believe that they can change. And guess what? When you believe that you can do all of those things, you're going to put in that effort. You're going to like stay up late. You're going to follow what the teacher is telling you to do, right? Like I give tips all the time. If you don't believe that you can do better in math or that you can be successful, like you're not going to apply what I'm telling you. Like, it's like you can join in on a live stream. You can write down like notes and you can watch this, live stream 20 times. But if you like internally do not believe that you can be better than what you currently are, you can change the way that your past has happened, or you can overcome struggles, you can overcome failures, then yeah, it's not gonna matter, right? So I think that's one of the key successful ingredients, because students that feel like they're not good at math, like they just believe like that's it. like, I'm just not good at math, and that's the way things were in my past. I don't feel like there's a future, for me in learning math. And yeah, I don't think I can get any better. I've tried, right? I've gone to tutoring. I've gone to see my teacher. Everything I've tried has never improved upon that. Well, guess what? There's more things that you can keep on trying to be successful, and that's what I want to kind of challenge with you. For on that is because the main thing here, guys, is math is hard, right? It's and I actually had my math is hard shirt, but I left it in my car and I didn't want to go back out and get it. But guys, math is hard, right? It is like everybody has to go through, you know, every single topic in the math. Nobody's jumping through over certain sections. And of course, yes, you can always relate to like, oh, well, this person knows how to do this so much easier, right? And like there's always the case. There's always that person. But I don't want you don't rely on your argument for like the one case or the one person in the class from on there. Math is hard for a lot of students. And it takes patience. You're not always going to get things immediately, right? Sometimes you got to let things sink in. And then also it takes time. You got to put in the time, you got to put in the effort, you got to put in the work. And then through all that time, you're going to get better and better at it, right? And through more experiences and more application, you are going to see that math is going to get a little bit easier. But guess what? There's always some math that's going to be harder waiting for you. So you just got to keep on plugging around. You got to release your previous failures and experiences. Understand that they are a part of you improving as a math student. Understand your purpose and why you're learning what you're learning. Why you need to be learning the material, even if it's for a grade or if it's for a certain course or a degree. And then also understand that you can make change and then you can do better. So hopefully this little talk was helpful, maybe a little inspirational or motivational for you. I know you guys are still kind of in the beginning of the quarter or like in that first semester, but hopefully you can, if you do need to make some changes or some adjustments, you have a little bit more time to be able to do that to wrap up the first semester. So, all right. I do have some couple more questions again, some math questions. If you guys do want to submit any of those to me, I'll go and push that back up there. So just a reminder, if you guys have any math questions, go over there. Otherwise, I'll just kind of head into the chat here for just a quick second. And see if there's anything on here for you guys. Riley says, I actually went from barely passing Algebra 1 to getting an A+ on my test in Algebra 2. Well, awesome, Riley. Good for you. Taking SAT in 2 days, any tips? I only laugh because I'm like, I don't think there's really anything I can tell you, Tristan, that really can like make a difference. I think right now within 2 days, you're kind of past the idea of like practicing problems, which I usually tell students to be able to do. So, you know what? I mean, I'd just probably maybe just review maybe some problems that you maybe have already completed, right? So try to go like, hopefully you've done some practice problems. I'd maybe just kind of review some of those problems, just for sake of time. Maybe review some, I wouldn't really maybe do a light review of like the formulas or stuff like that. I think if you've completed any problems, I would just try to review some of those, I think that's probably, you don't want to overdo it right now. You don't want to like over cram and be exhausted as you come into the SAT. I think one of the more important things is like make sure you get good rest, make sure you're not, trying to reduce your anxiety and stress, get some good food and, just do the best you can do from on there. Don't try to try and pull an all-nighters trying to learn everything you can. It's just usually just not going to go very well. Awesome. Yes. Well, go to brianmclogan.com/Q&A. And if you want to shoot me over a problem. Yes, Kenny, I have had a lot of students, usually every year. That was actually one of the harder parts of being a teacher was, having to go through that when students wanted to drop my class. And again, like students would drop my class for multiple reasons. Sometimes they weren't prepared for it. Sometimes they didn't like my teaching style. Sometimes, they were prepared for it, but they didn't get the grade they wanted, So, I mean, it was like every single situation was different. We always had to, address it separately. But yeah, it was kind of a difficult process. Radians too. Yes, the radians. Well, think about like the easiest way to kind of measure the rotation of a radian is take the radius, right, and wrap it around the circle. And that measure of rotation from the x-axis up to that point. And again, I have many videos from on there, but just the basic representation of a radian. If you can kind of think about taking the radius, wrap it around the circle, and that measure of rotation to kind of go through that arc is going to be a radian. But if you want to go and submit a question at brianmclogan.com/Q&A, I can probably go over a little bit better from there. Best of luck. Yeah, I mean, I like fully remote learning for some students. I don't think it's the best case for a majority of students. That's why I was always kind of, I was a proponent of like online learning when we had like a lot of the COVID lockdowns and stuff like that. But I was never really a big proponent of everybody being completely online from that. I don't think that was the best case for a majority of students. I think education is very powerful when it is in person inside of a classroom. And I don't think that's ever going to change. I don't care what comes up with technology, virtual reality, or whatever else. Like, we need students to be inside of a classroom with a teacher, and a high quality, strong teacher. And I think that's where students are going to learn the best. But again, like, that's not to say that that's the way education needs to be for every single student 100% of the time. Completely do not misconstrue that, because I definitely think there's students that can be completely virtual. I think there should be some hybrid examples, right? Just because where you live, let's say you maybe only have access to like one teacher or certain classes, like, you should not be limited just because where you live to access to that information. Or even if you're, inside a class, whatever else, like, you can be, taking other stuff for sure. Well, awesome. Gifts of honey. Happy to have it. What was the math like for you? We're good. I mean, math is like not really much changed. Actually I took integrated math when I was in high school, but yeah, it's basically the same. I was like my class, the way that I teach was not the way that I taught though. My class was definitely, when I was in high school, was very rigid. Like, we walked in, sat down in our rows, checked our homework, checked our homework, wrote down notes, and then yeah, had homework every night. Like, that was kind of like it. There was really no interaction or like activities to be doing. It's just basically like all lecture based. And yeah, so like, but obviously that was like for 45-minute classes, where the school that I taught at, we did 90 minutes. So you couldn't really do that. You could, like, there was a couple times I'd have to, but a lot of times, you had to break it up. You had to let students do some work, do activities, do fun stuff, cause yeah, when you're in math class for 90 minutes, like, that's a long time. We're doing continuity with limits in Calc 1 right now. Any tips to keep in mind with that subject? I mean, just make sure you understand your continuity, your continuities and your discontinuities, right? Your jumps, your holes, stuff like that. But yeah, I don't think there's anything in particular about that topic that I'd say to keep in mind. At least I actually got to go back through a little bit more on that, but nothing that I can think of anymore. Opinion. I haven't gone through the Alex program, so I'm not really sure on that. Yeah, I did some pretty like decent, decently strict, nothing crazy teachers, but yeah, I had some strict teachers, everything else. Struggling with pre-calculus 2 on trigonometry, but I've come to a realization that I will only learn if I dedicate hours to practice it. Well, yeah, absolutely. And guess what? Unfortunately, I have a ton of videos for you to practice from, and a ton of videos on trigonometry. But yeah, that's it. Like, I did a video, actually, it was like from 2 or 3 live streams ago, where like I talked about like the advice you don't want to listen to. It's on my channel if you want to look back into it. But like, this is exactly what I'd refer you to. Like, the advice that you don't want to hear, but that you actually need to, is like, most of getting better at math is just putting in the work, right? There's always these times, like, and that's why I do this Q&A, is like, because there's, something's like, I'm struggling with like this one point, or I don't understand how to do this one problem, right? And sometimes we make that out to be like, oh, I can't understand this, or this is so hard. And it's like, no, you just need to overcome that little gap. You just need to overcome that little, hill or mountain or whatever it may be. But you got to keep on working. You got to keep on putting in the time, the effort, and doing the problems. And you'll start to see the gains. And I think with anything that is, so much smaller increments, is like, when we don't see those initial gains, like I always think about like working out, right? If like, let's say you go to the gym one time, you're not going to like all of a sudden be like huge, big, and buff, right? But if you go to the gym, 1 day a week, 2 days a week, 3 days a week, 4 days a week, 5 days a week, like every month, every day in the month, every day, like for the next month, like you're gonna start seeing the gains, right? So, you got to put in that work and then kind of look back at it to kind of see how far you've really gone. And that's with a lot with math as well. Like you're not gonna all of a sudden like be doing a homework problem, like doing extra practice problems. Like, oh yeah, guess what? I got all A's now. Like, no, it takes time, right? And again, like the road is not like the road's ups and downs too. You can put a ton of time and effort into a class and still bomb it, right? And still not do good. So, but you got to get back up. You got to understand that, like, hey, I can do this. I can overcome this, and going from there. All right. I'm in 8th grade. I'm in 8th grade and I have trouble focusing in class as my friends are in it, and this leads me to not understanding the subject. Anything to help with this? I mean, yeah, you got to get away from your friends. I mean, I know it kind of sucks too, because like obviously it's fun to be in class with your friends, you're talking things, but like the reality is like they're doing exactly what you don't want like to friends in. Like they are impacting your learning. So maybe you can just have like a chat with the teacher and maybe have the teacher do it. I've had that before where like students have known, they're like, hey, this person, like sitting next to this person is my friend, but they like actually impact my learning. Like, can you move me? And I said, yeah, sure. So like, sometimes I would just like, as the teacher, I'd be like, all right, Susie, whatever, like you're sit over here. Like I'm changing your seat now. Right. So that was something I used to do for students like that. So I talked to your teacher about that and just like, hey, obviously these are my friends. Like I don't want to like not be their friends anymore, but I also want to do well in your class. This is impacting me. I don't want to be rude to them. Like I still want to be their friend and like, not like, you know, um, feel like I'm ignoring them because I'm, paying attention. Could you maybe like help me out? Maybe hopefully that will maybe help out. Awesome, Chris. Whoa, okay. Yes, exactly. Let me see. Are you still teaching kids math at a classroom? No, I'm not teaching inside the classroom anymore. Craig, I'd have to go back over through my calculus. I should remember at least the mean value and the average value, but my brain is already hurting and it's been a while since I've gone through calculus. So I'm trying to go back through the material so I can remember and immediately bring it back up to you. Oh, except for very welcome. So Craig, you don't need to keep on posting that. I don't have, but if anybody can obviously in the chat can help out or go onto the Discord, then I'll have to be able to help out from on there. Well, awesome, Tammy. Good for you. All right. So let me go and see. All right. We did get a couple more questions. Let me go and see if we got anything. Back on there. Do you still teach? No, I do not still teach. I do YouTube full time. I am happy to be able to help you out. You are very welcome. All right. Okay, I talked about remote learning. I know the answer. I just struggle with how to graph it in 3D. It's been a while since I've done some 3D. Yeah, it's been way too long since I've done anything with that. So unfortunately, Harris, I'm not going to be able to do that. All right. All right, guys, I'm going to go through the problems that were submitted on my channel. And therefore, again, if you guys have questions, feel free, you guys, you can always go ahead and remember, submit your questions each and every Sunday night at, you can go and submit your questions each and every Sunday night at Brian, where is this? There you go. At brianmcgolden.com/Q&A. All right, but any math questions, guys, keep them there. So therefore I can pull the picture. It's a lot easier than me trying to like read the chat and go from on there. All right. So let's go ahead and change this up. Sweet. Okay. So the student was asking this student was asking like how to do proofs. And It's kind of like a loaded question. There's a lot of ways for me to kind of approach this. So I can help answer this question, but basically like a proof is just a argument, right? So we're just laying down like the statement, right? And then we're given a reason for that statement. So usually the first one is going to always be dealing with, what is given, right? That's like the foundation. Like whenever you have like an argument, or a debate, like you have to like agree upon a certain number of facts, because if you don't agree upon a certain number of facts, then you can argue all night long and you're never going to agree on things, right? You're never going to agree on things if like you're looking at things from a completely different perspective than the other person. So first thing it says is AB is congruent to AC and AD is perpendicular to BC. So what I can say from there in this one is that's going to be our given statements. Okay, now in this one, like it looks like it's a multiple choice problem or something like that. What we're trying to do is I'm trying to see which of these statements does not justify any statement. So what I'm going to do is I'm just going to kind of go through the proof, and then I'll see if anything is what is on here, and then I'll just kind of cross it out. So the next one is measure of angle ADB. So let's like write out. So A to D to B, okay, is equal to measure of angle A to D to C. So these two angles are going to be equal to each other, and they're equal to 90 degrees, okay? So now what we've got to think about is like, oh, how do we know that those two angles not only are equal to each other, but they're 90 degrees? Now, there's really nothing that says anything in here. Like we don't really have a reason for that. So what we have to do is kind of go back to our given statements. Like what can we say from our given statements maybe that we can conclude that these two angles are not only equal to each other, but they're also going to be 90 degrees. And the way we can do that is we can look at this and say, oh, this perpendicular statement, right? When we say something is perpendicular, what that's going to do, like anytime you have a line and a perpendicular line, right? If we say this line is perpendicular to this line, what that means is that creates a 90-degree angle. Well, if you create a 90-degree angle here, you also create another 90-degree angle here. So this is going to be what we call the definition of perpendicular lines. Okay, and I'm just going to kind of keep that simplified just for the sake of writing. And then do we have that on here? Yeah, you can see D. So it's D is not the answer. Then it says AD is equal to AD. So say AD is equal to AD. Well, I think that's kind of obvious, right? AD, of course, is equal to AD. Like AD is the same line as AD. So of course it is. So that's kind of an obvious one. So sometimes what I will write is, or a lot of students, I'm like, at least as a math teacher, I was never picky. Like obviously I know as like math people, we want people to like know their properties and stuff like that. But if you just said it's like the same side, like to me, that made sense. That was justified. But you could also call that, what we call that is actually the reflexive property. And you can see that that is actually answer B. So we can see how that is now going to be defined there. So we have 90-degree angle and we have one side that is going to be shared. Then now it's saying, and now it's making the statement. Oh, I forgot. Whenever you're doing this, whenever you're going through given statements, it's also really important to go ahead and label your point. So it says AB is congruent to AC. Okay, so those two sides are also equal to each other. All right. So now let's get into this. So now it says triangle, side, angle, side. So triangle ADB is congruent to triangle ADC. So we need to be able to see, like, how can we say that those two angles are going to be equal to each other? Which of these reasons does not justify any statements given above? So why are these two statements equal to each other? Now you might say like, well, these are actually equal to side-side angle, right? And side-side angle does not prove that those are congruent triangles, and you're correct. However, there is also that HL theorem, right? At the hypotenuse leg. So side-side angle does work when you have a right angle, which in this case it does. So this one says is justified by side, angle, side. Well, no. There's no, like, we don't know. We don't have enough information to say like these angles, the included angle is going to be true. So this is going to be your answer, because that is not justified anywhere, right? It is still side-side angle, and it's what we call the hypotenuse leg theorem. And then the last one would be corresponding parts of corresponding triangles are congruent, and that's where you can do that then. So we call that one the CPCTC, right? So maybe sometimes you've said that because it's hard to sometimes say. But yeah, I always just kind of think about proofs as like, I'm just going to call this the HL theorem. I was kind of think of proofs as like, structuring up an argument, right? You got to have your foundation. You got to have things you agree upon. And then for whatever statement is being made, you got to have a justification for that. And usually thinking about, common sense, theorems, or previous statements that you can use. All right. Now this one, I really don't not sure what the student wanted me to go over. It says discover which cases will the inverse quadratic is not applicable. So like, I'm not really sure what direction they wanted me to go on. So I'm just going to do a little bit of an overview. All right. So here's a quadratic equation. Okay. Now, if you remember, quadratic or functions, for us to have the inverse, they have to be reflective about what we call the y equals x line. Okay, so this is y equals x squared. So the y equals x line. So actually, let's call this f of x. Okay, so if I'm going to be talking about f inverse of x, then what I'm going to do then is I'm going to need to reflect that about the y equals x line. Okay, so if you take this graph and reflect it about this graph, you're now going to have a graph that's going to look something like this. Okay, so this is what we call f inverse of x. All right, so it looks something like that. So this is your f of x. This is the y equals x line. And if you take those points and reflect it, then you have that. Now, what's the issue with this? Well, the issue with this graph is it does not pass the vertical line test, right? It fails the vertical line test. So therefore, f inverse of x is not a function, right? It's what we call not invertible in this case. So how do we know when a inverse quadratic is not applicable? We know that when it is not 1-to-1. So when it's not 1-to-1. Now, how can we tell if something is not 1-to-1? Well, the easiest way is we can use the horizontal line test. Okay, actually, I'm going to just write that in there. Line test. Okay, and basically 1-to-1 is that for every x you have a y, for then the y you're going to go back to that exact x. Okay, so you can see here how this fails the horizontal line test. Now, how can we get around that? How can we create cases where our quadratic is still going to be applicable, or the inverse is still going to be applicable to our quadratic? And that is going to be using. That is going to be using. What is the word that I'm trying to think of? Trying to say. That is going to be using our restrictions. There we go. So let's just kind of do two examples here. So what if I have y is equal to x squared plus 1? Okay, not y. Let's just do function notation. Actually, g of x. Okay. Okay, this is a problem. This is not invertible. And the reason being is because it does not pass the horizontal line test. Right? That graph looks something like that. So what can I do? Well, what can I do is I can add a restriction. What you want to do is find the vertex. So hopefully you can see here that vertex is at 0, 1. Okay. However, if I choose to the right of that vertex, or if I take the restriction to the left of that vertex, that graph is now going to be invertible. So let's say I do g of x. Let's change this problem to an x squared plus 1, where x is going to be greater than or equal to 0. Okay, so now that's kind of important because what does this graph look like now? Now this graph looks like this. Oops, sorry, not right there. Now it's only greater than or equal to 0. So the graph looks like that. So let's go ahead and find the inverse here. So if I did g, so to find the inverse, remember you can swap this as a y is equal to an x squared plus 1, right? Swap the variables. So x is equal to a y squared plus 1. Subtract 1, x minus 1 is equal to a y squared. Square root. And now you can say y is equal to, now I'm going too fast. Y is equal to plus or minus the square root of x minus 1. Now again, remember though, that's going to be a little bit of issue because if you were to graph that, x minus 1 is shifting the graph 1 unit to the right. Now the plus is going to look like this, and the minus looks like that. But remember, our graph looked like this. So you can see which one works, like which one looks like the reflection about the y equals x line. It's the positive one, right? Not the negative. So we're just going to kind of put an x on that, right? And the final answer is going to be f. Are we doing f or g? G. So my final answer is going to be a g inverse of x is equal to the positive x minus 1. All right, let's do another example. And this one, let's do a h of x is equal to a negative x plus 1 quantity squared. Okay, now this one looks a little bit different because what does this graph look like? Well, if we were to go ahead and graph it, all right, it's going to be reflected down and it's going to be shifted 1 unit to the left. Okay, again, it does not pass the horizontal line test. So how would this have to be restricted? Remember, it has to be restricted at its vertex. So again, like we have to apply, this is either going to be given to us or we're going to have to say like the only way this is invertible, the only case that this can be invertible is if this restriction is added, right? So it could be greater than -1 or it could be less than. For this case, let's do less than -1. Let's have a little fun. So now the graph looks something like this. Right? And you can say, hey, that passed the horizontal line test. This is now an invertible function. So let's go and figure that out. So if I was going to be invertible, that means I can find the inverse of this, right? So it'd be x plus 1 quantity squared. Okay, so swap the variables. X is equal to negative y plus 1 quantity squared. What I'll do is I'll divide by -1 on both sides. So I get a negative x is equal to a y plus 1 squared. And then I will take the square root of both sides. And then, so I have the square root of negative x. What am I doing? Negative x is equal to a y plus 1, and then I'll subtract 1 on both sides. So now I have a y is equal to a -1. Again, I'm sorry, forgot. Square root, that's going to be a plus or minus, right? Plus or minus. All right, so therefore I have y is equal to a -1. Let's put that at the end. Plus or minus a square root of negative x minus 1. Okay, now, remember, this is what our graph looks like. What does that graph look like? Well, it is a square root, right? Reflected about the y-axis, though. So now it's going to look something like this, and then it's being shifted down 1 unit, right? So it either looks like that, or it looks like that. So which of these, though, looks like it's a reflection about the y equals x line? Yeah, not this one, that one, right? So that is going to be the negative version, right? Remember, that's the graph that's going down. So my final answer is going to be, we're doing h, right? Okay. It's going to be an h inverse of x is equal to a negative square root of negative x minus 1. And voila. So there you go, ladies and gentlemen. Hopefully that was helpful for you. Sorry, guys, I didn't get into any more questions. But again, guys, the best way to be able to get your questions for next week is go to bradmcclothing.com/Q&A. And I'll be more than happy to get into your questions there. And that also just gives me time to get it set up on my live stream. So therefore I can answer the questions. But hope you guys have a great week. Hopefully, if you kind of join in late, go back to the beginning. If you've struggled with math or if you've had issues with math in the past, I hope that the topics, the thoughts that I cover can be beneficial for you and help improve your math in the long run. So otherwise, guys, hope you have a great night and great week. And I'll see you guys next Sunday. Cheers.